Good morning. Here we are again at Pilot Knob, a fairly distinctive feature in southern Madison County of Kentucky. I'll show you a picture of that here in a moment. Right there. The Pinnacles east of Berea, part of Berea College's property. But meanwhile, let's go back to our map. Today we're going to, in a previous video, I showed you how to take LiDAR data and construct a digital elevation model from it. I'll show you this is the 30-foot DEM from USGS, and so we can get 5-foot resolution here with the recently acquired LiDAR data from Kentucky. Today we're going to make a triangulated irregular network, a 10, and measure the volume from the base contour of Pilot Knob and measure the volume of the knob. So first let me turn on the contours, and you can't read it very well from here, but the 900-foot contour is approximately the base of the knob. I'm going to turn off these and actually turn these off for the moment. So what I first need to do is pick out that 900-foot contour. We'll use it actually a good bit later. So I'm going to start editing my contour, if I can find it. There they are. I've got a few things in NAT 83 and a few in WGS 84, which is why I'm getting that warning. So there's our 900-foot contour. I'm going to right click on that, go to data and export data. I'm going to save just the selected ones. Let's see, let's go to this folder here, and this is a line shape file I'm going to be saving, so I'll call it 900-foot line, and we'll save that and say OK, and let's add it as a layer. All right, we can deselect that now, and let's make it fairly fat and bold. Okay, now what we actually need is a polygon, so we're gonna, let me stop editing. Oh, yeah, that's right. Now what I'm going to do is, here in the same folder, I'm going to make a new shapefile, an empty polygon shapefile. So we'll call this one 900-foot poly, and it's going to be a polygon shapefile, and it's going to be in the Kentucky State Plane coordinate system. And I think everything is okay. Alright, now I want to start editing my new empty shapefile, and I'm now going to highlight that. I've got to have that closed line. It has to be a closed line, and I have to have it highlighted. And now I click on this little wrench looking thing. I'm going to use as the template my 900-foot poly, and we'll take the default cluster tolerance and say OK. Alright, there we are. We can deselect it now, and I think we should make it hollow. And let's actually turn off the line, and we'll make this sort of big and bold and colorful. Alright, there's my polygon. Alright, one other thing I have to do before we get to the making the 10 is I have to add a variable. I'm gonna let's see, I can't be in an editing session. Okay, now I'm going to add a field. I'm going to call it elevation, and I'm going to make it float, and okay. Now I'm going to go to the field calculator. I get a warning I can't take it back if I don't like it. That's okay. We can always delete it and make a new one. And I'm going to say elevation equals 900 for 900 feet and say okay. Alrighty. Let me go ahead and save things so that I don't lose anything. Okay, let me turn off the contours and let's bring back our detail, hillshade, and mosaic. So now I'm going to make a triangulated irregular network, as it's called, and use that plus this polygon to calculate the volume of Pilot Knob. So the all of what we're going to do now is within the 3D Analyst tool set, and under conversion from raster, I want raster to 10, and my input raster is going to be the Pilot Knob mosaic that we made in the previous video, and that's the right folder, and I'll call this one Pilot 10.2. Now the Z tolerance defaults to 10% of the total elevation range of the scene, and it maxes out at 1.5 million points. The 60, I'll show you one I've already done later, but this is too coarse. I think we can make a tolerance of 5 feet. This can take a lot of time to process if it's a big scene, but I think this won't take too long. Okay, not bad. So we can close that. And so now we have our 10, and we have our contour as a polygon. And so before I finish up here, I'm going to let me turn that one off, and I've done some 10s for the entire scene, the entire quadrangle, and there's the default, which for the entire N44 Big Hill quadrangle is about 95 feet, so that's really quite coarse. This one I believe was 25-foot tolerance, and then finally I did one at a 10-foot tolerance. Now that took a lot of processing time, so it's a trade-off. But anyway, here's our 10 back, and you can see a lot of detail. There's US 421 highway, there's Cowbell Creek, and so on, and some other creeks and roads and so on. In any case, let's go back to here and calculate our volume, and this is, once again, it's under the 3D Analyst, under triangulated surface, and we want polygon volume, and the input surface is going to be my pilot 10.2, my input feature class is going to be pilot poly. I'm sorry. It's going to be 900 foot poly. There it is. All right. The height field is going to be elevation. We want to measure above, and the volume field will be the volume field, and we'll say OK. Okay, our volume is output to this 900 foot poly, so we have our volume in cubic feet, and then the surface area, if we were interested in that as well, in square feet. Let me see, let's do one other thing. Let's add a field, and let's call it volume cubic miles. This isn't really a very good unit because it's so small, but just to show you how it's done, and we'll make that float and say OK. And volume in cubic miles, we'll do the field calculator, ignore the warning. Volume cubic miles is going to be equal to volume divided by the number of cubic feet in a cubic mile. That would be 5,280 cubed, and we'll say OK. And it's about 5/1000ths of a cubic mile, so that's not a very convenient unit either. In any case, cubic yards or cubic meters might be a better one, a little more manageable than either cubic feet or cubic miles. In any case, that's how you take a DEM, produce a 10 triangulated irregular network from it, and calculate a volume of some feature you need to. Volume of a lake, a volume of a mountain, volume of an ore body, and so on. So, thank you very much.